Welcome back to the Nerdwork Nexus, ready to dive into something pretty wild. It's mirror life. Sounds a bit sci-fi, right?
Yeah, it's definitely got that out there quality to it.
But it's actually some serious cutting-edge synthetic biology, and, well, there's some potential for things to get a little unsettling.
Yeah, I'd say so.
But that's why we're here. We've got research from some major universities, policy recommendations from a whole group of 38 experts, even some pieces that get into, like, the ethics of it all. So,
Wow.
yeah, right.
Yeah.
So this is for you, whether you're, a bio researcher or maybe more on the policy side or even just a, science fan. This stuff it's important. We're going to break it down, the whole science behind this mirror life, look at the potential risks, and they are big.
Yeah.
And then think about, like, what can we actually do about it, before it potentially becomes a problem.
Definitely feels like a now conversation, not a later one.
Absolutely. So maybe, like, start with the basics. What is mirror life?
So we're talking about organisms that are like literally flipped. Like imagine looking in a mirror, but at the molecular level.
Okay.
All life on Earth, we use left-handed amino acids
Right.
to build proteins, and then right-handed DNA and RNA for the genetic code.
Right.
Mirror life. Opposite. It's all reversed.
Whoa. Okay, so, like, what does that even mean for us if these mirror image organisms, like, were actually real, walking around?
That's where the incompatibility problem comes in, right? And it could get, well, kind of dangerous.
Right.
Think about it. Organisms that maybe our immune systems don't even recognize.
Ah, so they just fly into the radar.
Exactly. Antibiotics, useless. Natural predators, can't control them. Basically, it's like a superbug, but amplified, Completely alien to everything we know.
Okay, so I'm getting chills here. But, like, hold on. Haven't scientists created mirror life yet? This is all hypothetical, right?
It is hypothetical, true. But a lot of experts think we're way closer than most people realize. Yeah, that's why this is so important right now. The advances in synthetic biology, even minimal cell development, it's all moving so fast. Some researchers are saying we could be just a few decades away, like 10 to 30 years.
Oh, wow. That's a lot sooner than I thought.
Mm-hmm.
Okay, but knowing, like, how risky this could be, why are scientists even thinking about making mirror life? What's the good side?
The potential benefits are huge, especially in medicine.
Okay.
Imagine drugs, mirror image drugs that last so much longer in your body. Our enzymes, they wouldn't break them down as easily. That would be massive for, like, chronic illnesses.
Oh, I see.
Plus those mirror bacteria, they could be like little factories, churning out these drugs way more efficiently than anything we've got now.
So it's like this crazy trade-off, huge medical breakthroughs, but, like, this looming biosecurity threat. What are the actual specific risks scientists are worried about?
Accidental release from a lab is a big one.
Yeah.
Even with the best containment, things happen, right?
Always, always.
And if mirror bacteria got loose, it could be a pandemic unlike anything we've ever seen. Immune systems would be defenseless, and, well, the consequences could be really bad. Really bad.
Yeah, no kidding. And it's not just accidents, is it?
No, not at all. Unforeseen evolution, that's another worry. We just don't know how this mirror life would adapt out in the world. Could it compete with regular life, cause ecological chaos? Could it find ways to, like, get around our defenses and become even more dangerous? These are big unknowns.
And what about bioterrorism? Like using mirror life as a weapon?
That's very real. It's actually what prompted 38 scientists from all sorts of fields, immunology, synthetic biology, the whole spectrum, to publish this policy form. They're calling for basically a halt to research that's directly trying to create mirror bacteria, at least for now.
Yeah.
Until we have a serious global conversation, we need to talk about the risks, the ethics, all of it, before it's too late.
That makes sense.
Yeah.
So they want to hit pause, but I guess they're still okay with research on the individual molecules for medicine, right?
Yeah, because those wouldn't, like, self-replicate and go rogue.
Okay, that makes sense. Less chance of, ecological disaster. But I'm guessing not all scientists are on board with this research ban. What are they saying?
Well, one argument is that even if we made mirror bacteria, it wouldn't survive out in the world. Like, it wouldn't be strong enough to compete.
So natural selection would take care of it.
That's the idea. Others say the scientific benefits are just too big to ignore, and that stopping now is, well, it's too early. They think we should just move carefully, have really tight safety measures, instead of stopping progress altogether.
It's so interesting to see both sides. It makes you realize, like, how complicated this is. It's not just about the science. It's about, like, what we value as a society, what we're willing to risk.
Absolutely. And that's why we have to have this conversation now. We need to make informed decisions.
Yeah.
And that needs open and honest dialogue.
So even if we ban the bacteria research, what about, like, more complex organisms? Are we opening some crazy Pandora's box here? Could there be, like, a whole mirror ecosystem, like a shadow biosphere, coexisting with our own?
That's the big question, isn't it? I mean, it sounds like sci-fi, but it's a possibility.
Mind-blowing. Okay, let's get practical for a minute.
Mhm.
What can we do? Like, if these experts get their wish and we start having these international discussions about regulations, what would those even look like?
Probably a multi-layered approach, right? First, we got to define what exactly is mere life research. Where's the line?
Yeah.
Like studying individual molecules for medicine, that might be okay. But creating whole mirror organisms that can replicate, no way.
Okay, so drawing a clear boundary.
Exactly. Then you'd need serious oversight, like registering all research projects, inspecting labs, having super strict protocols for handling anything mirror image. Think like nuclear non-proliferation. You got to be that careful.
That sounds about right given the stakes. And this can't be just one country saying no to mirror life research, right?
Nope. Needs global consensus. Everyone playing by the same rules.
And we can't keep this all hush-hush. People need to understand what's going on.
Right. Open communication is key. The public needs to know the science, the risks, the whole picture, so they can be part of the conversation, make informed decisions.
Exactly. This isn't just scientists deciding behind closed doors. It
Yes.
affects us all. This whole mirror life thing, it's really pushing us to, like, rethink what life even means, isn't it? Like, we've always assumed what we know is it. But maybe there's other life out there, even here on Earth, that we just haven't been able to see because we've been looking for the wrong things.
That's a really good point. It raises some huge questions. If we do make mirror life in a lab, what does that say about how life began? Was our chirality, the left-handed amino acids, right-handed DNA, was that just random chance? Or is there some reason why life on Earth developed the way it did?
Ooh, deep thoughts.
Yeah, it is pretty mind-blowing. And then it makes you think, if it's possible here, could it be out there too? Like on other planets, whole mirror ecosystems.
Like, we're looking for signs of life on Mars and Europa. But what if we're missing something because we're not looking for the right signs?
Exactly. It's something astrobiologists are starting to think about. The search for alien life might need to, like, broaden its scope.
Wow. So this isn't just about risks and regulations. It's like it's changing how we see life itself, here and out there.
It really is. And it has ethical implications that go way beyond science, too. We're talking about, like, creating a new form of life. And that brings up some heavy stuff.
Hmm.
Philosophical questions, even religious questions, like, do we even have the right to do this, knowing the risks? And what about if we actually create it? What do we owe it? Is it just a tool or is it something more?
Yeah, there are no easy answers there. Makes you realize we need more than just science in this conversation, right?
Yeah.
We need, like, ethical guidelines.
Definitely. And it shows how important it is to have different fields working together. Scientists, ethicists, policymakers, we all got to be at the table making sure these technologies are developed responsibly for everyone's good, not just, for the sake of progress.
Yeah, it's like science needs a conscience. We can't just chase the what. We need to think about the why and the how, too.
Exactly. I think that's a big takeaway from all this mirror life stuff. It reminds us that science isn't, like, neutral. It's a powerful tool, and we have to choose how to use it so we don't, accidentally unleash a bioapocalypse.
Right. Okay, so let's shift gears a bit. Imagine you're a doctor,
Yeah.
right? And you've got a patient who's, well, they're sick, looks like an infection, but nothing works. The tests, well, confusing. Could that be our first sign of mirror life, like out in the real world? How would we even know? What would we do?
That's the kind of scenario that, well, it worries a lot of people, and not just doctors. The truth is, we're pretty unprepared for something like that. Our tests, our treatments, they're all built for the life we know, not its mirror image.
So we'd basically be starting from zero.
Pretty much. And with no time to waste.
Would we need new antibiotics, like a whole new way of thinking about our immune system?
Yeah. Massive research effort, a total rethink of how we fight diseases. And it wouldn't just be medicine either. We'd have to figure out the environmental impact. Could be like total ecological chaos, a global crisis on a scale we haven't seen before.
It'd be like an alien invasion, but from right here. Which, speaking of aliens, we're always looking for life out there, right? But we're looking for stuff that looks like us, basically.
Yeah.
What if we're missing mirror life forms? Because we're just not looking for the right things.
That's a good point. Astrobiologists are starting to consider that now. I mean, if it's possible here, why not out there, too? It opens up a whole new world of possibilities in the search for alien life. Maybe we need to completely rethink our search strategies, like even what we consider life in the first place.
It's kind of humbling, right?
Hmm.
To think we might be so wrong about, well, everything. It makes you realize we need to be really careful as we explore these new frontiers of science. We got to be humble, cautious, and really think about the consequences of what we're doing.
Absolutely. We're dealing with forces that could completely change how we understand the universe, how we understand ourselves. And that's not something to take lightly.
So for all our listeners out there, the biologists, the policy folks, even just the curious ones, what's the one thing you really hope they take away from this?
I think it's that the future isn't set in stone. We have choices to make. And those choices, they have big consequences. Creating mirror life isn't something that's just going to happen. It's a path we could choose. But we need to be really careful about it. We need to weigh the benefits and the risks, and we need to get everyone's input. This is a conversation we need to have now, not later.
Yeah, it's a reminder that science isn't just this neutral thing. It's a powerful tool.
Yeah.
We get to decide how we use it, what kind of future we want to build.
It really makes you think, doesn't it? Like about the big picture. And it brings up another thing. This isn't just about bacteria. We've been talking about that a lot because, well, it's the most urgent thing, right? But what about like creating mirror animals, mirror plants? Where do we even draw the line?
Right. Like once we open this door, how do we decide what's okay and what's not?
That's exactly what people are trying to figure out right now. Scientists, ethicists, policymakers, everyone's starting to realize we need some kind of framework, like a way to evaluate this research, not just each individual experiment, but like the whole thing, the big picture.
So we need some rules,
Yeah.
some ethical boundaries.
Mm-hmm.
But who gets to make those rules? This is a global thing.
Oh, absolutely. One country can't decide this, not even just a group of scientists. We need everyone at the table. International collaboration, open discussions, scientists, ethicists, policymakers, and like regular people too. Everyone's got to have a say.
Yeah, because this is about the future of life, and we got to get it right.
Exactly. And to get it right, we need to be informed. We need to understand the science, the risks, the good things that could come out of it. And we have to think about the ethics. This is what these conversations are all about. That's why we're doing this deep dive, so people can learn and think and, start talking about this stuff.
So for everyone listening, whether you're like in a lab or in government or just, someone who loves science and wants to know what's going on, what can we do? How can we make sure we're making good choices?
Stay curious. Keep learning. Follow the research, talk to experts, ask questions. Don't be afraid to get into the complicated stuff, even if it makes your head spin a little. And get involved. Talk to people about this. Write to your representatives. Make your voice heard. This isn't just about science. It's about all of us.
I think that's a great place to wrap up. This whole world of mirror life, it's amazing and it's scary and it makes you think about, well, everything. But we can't ignore it. So stay curious, stay engaged, and let's work together to make sure the future, all the futures, the mirror ones and the ones we know, are good ones.
Yeah.
For everyone.
Well said. That's what makes scientific exploration so powerful and also so important. It makes us think bigger, question everything, and create a future that's actually, the one we want. So until next time, keep exploring.